Okay, so we're back today with sort of a continuation, I guess, of the solar install surrounding a component within it that um, was something that I had never really messed around with before, and made some mistakes pertaining to it. So, if you've been following along, the piece of equipment that I originally put in the fifth wheel was a 24 volt to 12 volt step down converter that I shorted out by mistake, and because of the fact that there wasn't a fuse to protect the rest of the system from catastrophic failure, it burnt up pretty good and caused some damage. So we ended up replacing that, of course, and fixing the damage and everything. At least in my mind, was fine. I replaced it with a Victron one, installed it, and away we went. So um, the problem that I had is that sort of in the process of going through all this, the installation of the converter sort of evolved, because we have a little solar panel on the roof of the trailer that was originally responsible for trickle charging the existing 12 volt system that was on the trailer from the factory. And we decided that we wanted to bring that back into the equation, so that we had kind of like a miniature 12 volt system that was responsible for running the fridge and the slides and so on and so forth. So basically, that meant introducing a 12 volt battery. So to kind of go back a little bit, the majority of our system that involves the inverter that is going to run our microwave and our air conditioner and basically all the larger AC loads in the trailer is handled by a 24 volt battery bank that's fairly considerable in size. It's 450 amp hours at 24 volts. And what I was originally planning to do was just put a converter in there that would take the 24 volts, step it down to 12 volts, and then just plug the 12 volt part of the trailer directly into that, having the larger batteries run all those 12 volt things as well. So that, like I said, that sort of evolved into bringing this solar panel back in and then introducing a battery. So the issue that we're having is that that converter is basically not the right piece of equipment to do that kind of a job when you have a battery on both sides of the conversion. Um, and the reason that it isn't is because I, at the time, didn't realize that there was differences in how these different converters work. So basically, what you have here in a normal type of a situation is that you've got a conventional path of current and then also an electron path of current going back. So originating from the battery, we've got current that travels in this direction to the load, and then you have an electron path that travels from the load and then back to the battery in this direction. And that's basically a simple diagram of nothing more than just a battery headed towards a load on the other end. So what I did is I put in, because we wanted to have a 12 volt battery at this end and a 24 volt battery at this end, um, and then our 12 volt loads plugged into this 12 volt side, and then our inverter plugged into this side. I had to introduce a converter, a 24 to 12 volt converter, which is what this is. Now, the problem with this is that I didn't know at the time, but there is isolated converters and non-isolated converters. And the one that I purchased was a non-isolated converter. So what that means is that you've got your 24 volts current traveling this way into the converter, and then your negative is in common with the other side. So you've got this sort of like weird kind of thing going on here that was causing us a problem. So you've got on the negative side of the battery as it travels over here. Um, we've kind of got both of these systems trying to feed power into this same sort of thing, and the negative electron side of it is trying to kind of go back this way. But it's because this negative is in common with both sides, there's like coming and going, and it was just creating this whole big mess. So I had a diode that I installed that took care of making sure that the positive current couldn't return back. But the issue that we had after a few days is that that diode became smoking hot, and this 12 volt side was discharging back into this whole sort of confusing mess where basically so that resulted in this battery going dead all the time, even though it wasn't doing anything. So the solution to it is to introduce a isolated converter instead. And we actually went one step farther this time and actually did a 24 to 12 volt charger instead, which works, you know, similar in a lot of ways. But now I have some decisions that I can make as to how much current I want to let through. I can allow the system to fully charge the batteries on this side if I want, or I can just have it work as stable power so that that battery won't drop below a certain set point. But the way that this one works now is that these two systems are completely separated from each other within the conversion process. So you've got your positive coming in to the 24 volt side, traveling back out on the negative side, completely separate. And then the same thing is on this side. So there is a conversion process that takes place here, but because the negatives are completely separated from each other, we don't end up having this sort of crisscrossing back and forth thing that was causing all kinds of problems by trying to have a battery on this end. The style of converter that we had was meant for nothing more than having a load on this side that operates at 12 volts. It is not designed for having a storage device like a battery on this end that actually has an ability to discharge power back into the whole system, where this negative is shared between both sides. Now that all said, I would like to remind everybody that I'm not an electrician or have any certification in solar or electricity whatsoever, but I do have a pretty good understanding of how it all works and how it all goes together, with the exception of this one thing. So that's my theory anyways as to what was causing the problem, but it's very likely by no means what actually happened. I am feeling like pretty well 100% confident though that by switching this component that the problem that we were having, whatever the reason was for it, is going to be resolved. So this is the one that I just pulled off the wall, and you can see standing next to the other one that there is a considerable difference in size, as you can imagine, because the two sections in this one are completely isolated from each other. So for all intents and purposes, it's like having one of these on this side and another one on this side, where the conversion process is allowed to take place, but the systems themselves remain independent from each other. So we went one step farther by doing a DC to DC charger in this case. And one of the things that I'm excited about with this as well is that you can see the Bluetooth symbol here. So this one will actually go on the Bluetooth app that Victron provides, and I can keep track of it there. From what I understand anyways, I should be able to turn it on and off, allow it to fully charge the 12 volt batteries if I want to, or just set it up to be stable power to those 12 volt batteries at a constant voltage, whatever that may be, 12 volts, 12 and a half volts, or whatever. I guess I'll see once I actually get it energized and be able to play around with it. But that's what's going to go up in the location where that little one used to be. Plus, I've also got the proper breakers now, so I have removed those from here as well so that I can install the correct ones, which look like that, but they're 30 amps instead of 60. And then it is also my opinion now that with this charging system in place, that this diode that I originally thought was going to resolve the problem I was having will be made redundant. So that's coming out as well. Okay, we've got the old one down, the new one up. Everything is all hooked up. I've got the two new breakers in here as well. And everything is connected. So I'm just waiting now for the charger to do a couple of updates, and then we'll see what's all involved in setting it up. Okay, so we're done doing our updates. Let's go in here and see what's going on. And it's currently in charging mode. 26.6 coming in, 14.1 going out, and it's in bulk mode, similar to what you would see on a solar controller. So in the settings, we're in charger mode. We've also got power supply mode, which is going to maintain a voltage coming out at 12.5. And it looks like that's about the only thing that you can change here is you can adjust what you want that voltage to be. I think 12.5 seems like a good starting point as far as using this as a power supply. Yeah, and so then that main screen adjusts itself now to power supply mode at the top, and just kind of tells you what the voltage on the battery is right now. So I guess therefore it's not doing anything given the fact that the battery is higher than the power supply voltage that we've set up. So let's just go back to the charger again. And then we'll go into battery settings. This is actually very similar to what you see on the solar controllers as well, with regards to choosing the type of battery that you have. In our case, we've got lithium iron phosphate on the 12 volt end and on the 24 volt end. So it's gone ahead and made the adjustments for that. What else can we do? Automatically calculates absorption time. I do believe that the way that the solar controllers work is they just kind of cap you out at, I believe it's 4 hours for absorption, and then it goes into another absorption mode the next time the batteries need to bulk charge. This can be used in a van as well, where there's a alternator hooked up to this, so you can configure this to shut itself down when it detects that the engine isn't running. That's not how we have ours set up. There is no engine connected to this, so I'm just going to leave that off. And it looks to me like that's basically it in a nutshell. The only other thing that needs to be done, I guess, is to... Can you... I was gonna say I don't know if this will go on the network with the other stuff. It doesn't. I don't see actually where you do that, but I do like though that it's on here and we can sort of monitor this with the rest of the systems that are all kind of interconnected here as well, and then I can kind of keep track of where that smaller battery is at, not only off the charge controller but off the charger itself. And if we want to, we can move a charge over if that one is getting low, and the big batteries are full and have have more than enough capacity to move over to the other one if we've had a couple of cloudy days, and that 50-watt panel that's up there doing the trickle charging is not keeping up, which I think probably will happen fairly often, honestly. But so it's kind of nice knowing that we've got some options here. So that is it for this one. Pretty straightforward to put in. Not a whole heck of a lot actually going on to set it up. There is some different things that you can fiddle around with absorption, voltage, and things like that, which I may play around with a little bit in the future. But for now, I'm just going to use the preset that Victron has got in there, and that ought to take care of this problem once and for all.